Let's solve question 4 here. Please write. Find the work done in an electric field if the electric potential difference between 2 points is 50 volts and the external agent carries a charge of 60 microcoulomb. We are given options here. They said A 300, B 21, C 31, D 42. Let's solve this here to know the perfect option solution first. To find potential difference related to work done, we use this formula, that is VB minus VA. This represents potential difference, please take note, is equal to work done from A to B over Q. This work done here represents external work done moving from point A to point B. We use this formula here to calculate potential difference related to work done. Let's know the parameters given to us from the question here. From the question here, VB minus VA is given to us as 50 volts. The charge here is given to us as 60 microcoulomb, and this micro here is a prefix in mathematics representing times 10 raised to the power minus 6. Please take note. So when you express this here, we have this to be 60 times, that is charge here, will be equal to 60 times 10 raised to the power minus 6 coulombs. And then we are asked to find the external work done. All right, let's replace the value here using this fundamental formula given to us here for electric potential difference. Okay, when you replace the parameters here, we have this is 50 is equal to work done, that is moving from A to B, over the charge is given to us as 60 times 10 raised to the power minus 6. So make external work done the subject. We have something like this. External work done is equal to 50 times 60 times 10 raised to the power minus 6. When you punch your calculator, we have something like this. That is 3000, that is 123 times 10 raised to the power minus 6. So let's convert everything to standard form. From this point here, we'll have this in standard form as 3 times 10 raised to the power 3 times 10 raised to the power minus 6. That is this 10 raised to the power minus 6 here. So from the law of indices, I have this to be 10. I have this to be 10. You take 1. So the base are the same. We take 1. This will be 3 times 10 raised to the power 3 times 10 raised to the power 3 minus 6. Our final answer here will be 3 times 10 raised to the power minus 3. And the unit here is joules. Please take notes. So this is our answer. Let's solve the next question, question 5. Let's solve question 5. Question 5 said, calculate the electric flux through a spherical surface of diameter 50 cm if the magnitude of the electric field is 120 Newton per coulomb and makes an angle of 30 degrees with the unit vector. A, the options are given to us here: 653.05, B 81.6, D 411, C, sorry for that, this C 411 D 317. Let's solve this here. Solution. When we are asked to find or to solve any equation related to electric flux, we apply Gauss law. And we have a lot of formulas for Gauss law. The first one is we have a lot sorry we have a lot of formula for electric flux. Whenever we're asked to find or solve any equation related to electric flux, we apply Gauss law. And we have a lot of formulas for electric flux. The first one is related to charge, while the second one is related to electric field, while the third one is related to electric field with an inclined plane. So the first formula we have here related to flux from the law of Gauss law. From Gauss law, the first one here is phi is equal to charge, that is enclosed charge or net charge, over epsilon naught. The second one related to electric flux is electric flux phi is equal to EA, where E represents electric field, A represents an area, and this area depends on the charge. Sorry, this area depends on the shape. Please take notes. And the last one here is EA cos theta. This is used for an inclined plane. Please take notes. So if you look into the question here, we are given theta, which is an inclined plane, and we are also given electric field. So the formula to use at this point is the third formula. So using the third formula here, that is using phi equal to EA cos theta. From the given parameters here, we know that E is electric field, A is area, and it depends on the shape in that particular question. Please take notes. The theta here is the angle. So let's add the parameters here. E from the question is 120 Newton per coulomb. Area, the shape there is a spherical shape, so we have the area of a sphere to be 4 pi r square, and what is given to us here is diameter. So let's calculate the radius here. From the formula here, radius is equal to d over 2, which is equal to diameter is given to us as 50 cm. Convert 50 cm to meter, we have 0.5. So I'll have this to be class 0.5 divided by 2. So our radius here will be equal to 0.25 meters. So when you calculate the area here by replacing the value of the radius, we have area here to be equal to 4 times 3.142 times 0.25 all square. We are using this formula here. Please don't forget, when you point your calculator to find the total area here, we have this to be 0.7855 meters square. So let's replace all the parameters to find the electric flux. Remember, we're asked to find electric flux from the equation. So solving for electric flux here, electric flux is equal to, from the formula, EA cos theta. Representing the parameters, this is 120 times area is 0.7855 cos 30 degree. Okay, so this will be equal to 120 times 0.7855 will give us 94.26 times 0.8660. When you punch cos 30, we have this. So our final answer here will be equal to class 81.6316 in Newton meter square per coulomb. So this is our answer here. Please take note. Question said capacitor of capacitance 0.05 microfarad receives a charge of 0.2 microcoulomb. What is the potential difference of the plates of capacitor? Now we are given a capacitance, that is a capacitance is given to us here, and also we are given charge. We are asked to find the potential difference. Calculating potential difference related to capacitance, we use this formula. Solution first. We use this formula here, that is using C equal to Q over V. All right, now from the question here, the charge is given to us. The charge is given to us as 0.2 microcoulomb. Replacing the prefixes, we have this to be 0.2 times 10 to the power of minus 6 coulombs. The capacitance is given to us as 0.05 microfarad. Replacing the prefixes, we have this to be 0.05 times 10 to the power minus 6 farad. All right, now let's make potential difference the sublet of formula from this formula given to us. When you do that, V will be equal to plus Q over C. Let's replace the values. This is 0.2 times 10 to the power of minus 6 over 0.05 times 10 to the power of minus 6. All right, this we cancel this. I'll be left with potential difference will be equal to 0.2 divided by 0.05. When you punch your calculator, we have the answer to be 4 volts.